pens is normally distributed with a mean of 11 hours and standard deviation of 15 minutes. So the first thing you have to realize is that the mean is given in terms of hours and standard deviation in terms of 15 minutes. So yeah, part A. So we have to basically just find the probability of use time greater than 10.5 hours. That would just be PR 10.5. And you can just evaluate that on your CAS and you get 0.977. And bear in mind that standard deviation is a quarter of an hour, not just 15 minutes. Part B, we're moving on to grade B whiteboard pens now. And we're given the probability density function below. And part B asks us to find the mean of the function. So what we just do is E of x integral of 0x f of x dx. And you can evaluate that on your CAS and get 7.75 hours. Part C, they want us to find the standard deviation now. Another simple question. The formula here is you can just evaluate this on your CAS to get 0.31 hours. Okay, part D. Now we just have to find the probability that use time is greater than 10.5 hours for grade B whiteboard pens. And that would just be PR is greater than 10.5 equals 12, because that's the maximum value that the function can take. That simplifies to 0.1134. Now we're moving on to the different section of the question. In this part, there's this worker and he's selecting pens from different boxes. One box contains only grade A pens and the other box contains only grade B pens. And he randomly selects the whiteboard from each box. Now we're given a couple of conditions. If the use time is greater than 10.5 hours, the box is labeled grade A and the other box is grade B. Otherwise, the box it came from is grade B and the other box is grade A. So now we want to find probability that the worker labels the boxes incorrectly. So PR labeled incorrectly. Essentially, probability of A and A is less than 10.5 plus probability of B and X is greater than 10.5. And that's basically half times, because you have a half chance to select box A. Your answer from part A, I think, comes in handy here. 1 minus 0.977 plus half times your answer from part D can be used here, 0.1134. And that answer simplifies to 0.068. Part F, now we want to find the probability that the whiteboard pen selected was from grade B, and conditional probability now as well, given that the boxes have been labeled incorrectly. That would just be PR B given labeled incorrectly. And that's the intersection of B and labeled incorrectly. divided by PR labeled incorrectly. This numerator here is essentially half times your answer from part E. Oh, sorry, part D. Yeah, that's 1, 3, 4 divided by your answer from part E because labeled incorrectly. Just found that. That simplifies to 0.833. Part G. So we're given the definition of defective now in terms of this question. And we're given a company that tells us that 5% of grade A whiteboard pens will be defective, given that the stock is 2 years old as well. Part G, the important things to note is there's a class of 26 students, and at least one student will receive a defective whiteboard pen. That's what we want to find. So first of all, we have to notice that n equals 26 and p equals 0.05. Now to find PR x is greater than or equal to 1, essentially 1 minus PR x equals 0. And that's going to be 1 minus 26 students. And we want 0 to be defective, which means 0.05 to the power of 0 multiplied by 0.95 to the power of 26. 26 choose 0 is just 1, and 0.05 to the power of 0 is 1 again. So it's just 1 minus 0.95 to the power of 26. That's 0.7365. Part H, moving on to sampling. Sample proportions of defective grade A whiteboard pens come in boxes of 100. And we want to find probability of this. And we can't use normal approximation as well. So PR had a 0.04. This equals divided by so now we want to find it in terms of x and get rid of these decimal points and make it in terms of greater than or equal to or less than or equal to as well. So then we can do it by cas. So to make it in terms of x, it's going to be PR 4 less than x, which is less than 8, divided by PR x is less than 8, and satisfy the other condition we need. And then you can evaluate this by CAS and you get 0.5000. That's part H. Part I, we know that it's found that 6 of the whiteboard pens are defective, and we have to determine it at 90% confidence interval. So P equals, I'm going to use formula for this question, not CAS. There are 3 things that we need to know. Now we just have to plug that into this formula here. By n p hat plus k hat divided by n. I think, yeah. And once you plug in the numbers over here, you get 0.02, 0.10. To do this by CAS, you can just use one prop C interval and just fill out the relevant values, and you get the same answer as well. Okay, that's 2017 done. I'm going to move on to 2018 short answer for probability. In this question, we're given 3 types of components, and those are sensors, motors, and controllers. And it's known that 8% of all of sensors are defective. We're given the fact that a random sample of 5 sensors is selected, and we have to find the probability that exactly 2 of these selected sensors are defective. So to do that, we just use binomial. Random sample of 5, and we want 2 of them to be defective. Chances of being defective is 0.08 to the power of 2 multiplied by 0.992 to the power of 3, which is 0.0498. Part II. Moving on to conditional probability, as we can tell by the word given. So PR x equals 2, given that x is equal to 2, which is this. And this simplifies to PR x equals 2 divided by PR x is less than or equal to 2. I can just use your answer from the previous part and just sub that into the numerator, and then evaluate the other part of the fraction with your CAS. You get this, and when you simplify the fraction, you get 0.0501. Part B, we're given that a random sample of 50 sensors is selected, and 0.08 of these are defective, and we have to determine a 90% confidence interval again. I don't have enough space here to write down the formula, so I think it would just be best to use CAS, but I'll just write down the values we need to know. P hat is 0.08, N equals 50, equals 645. This was if I was to use the formula. And the approximate confidence interval for this proportion is 0.0169, 0.1431. In this question, the depth of the hole is normally distributed, and we're given the mean is 20 millimeters and standard deviation is 0.3 millimeters. And now they want us to find the probability that the hole is greater than 20.6 millimeters. That's essentially the CAS question. Just evaluate that and you get 0.0228. Part D. Now we have to see that the depth has to be within 0.5 millimeters of the mean, otherwise the motor is defective. So now they want us to find the probability that a motor is going to be defective, and valid values that are 0.5 meters away from the mean are in between 19.5 and 20.5. Hence, probability defective is PR 19.5, and that when you evaluate that, you get 0.0956. Part E, Rebecca delivers an order for 5 sensors and 5 motors, and we need to find the probability that the order contains exactly 2 defective components. So the combinations to get 2 defective components are 2 sensors I'll just write S for sensors and M for motors, just to save space. 2S, 0M. That gives us 2 defective components. Then we can do 1S and 1M. And finally 2M and 0S. I'll just erase that now, just to save space. So first of all, we have to evaluate the probability of each of these combinations from happening. So let's do this. The probability of getting 2 defective sensors is your answer from part A. We found that up here, so we can just do 0.498 multiplied by when motors is 0. To find that, we can just do 520 because we want 0 defective motors multiplied by 0.0956 of 0 times 0.9044 to the power 5. And that's going to be 0.0498 times 0.6051. That's one combination done. Second combination, we want to find one motor and one sensor each are defective. So now we have to evaluate this. Start off with the sensors. 5 choose 1 times 0.08, 0.92 to the power 4, multiplied by 5 choose 1, 0.956 times 0.9044 to the power 4. That simplifies to 0.2865 times 0.3197. For our final combination, we need to find when there's 0 defective sensors and 2 defective motors. And that's essentially 0.08 to the power 0 times 0.92 to the power 5. This is just 1, this whole block. Times 5 choose 2, 0.0956 squared times 0.9044 to the power 3, which is 0.659 times 0.66708. And to find what the question is asking us, which is exactly 2 defective components, we add up the values we got from each combination. And once you add those up, you get 0.166. Part F, the knobs attached to each controller and the height of each knob is normally distributed with a mean of 30 millimeters. And if the height of a knob is greater than 30.4 or less than 29.6, the controller is defective. Rebecca wants to ensure that less than 2% are defective. What's the maximum standard deviation? That's what they want us to find. All right, so we can see that PR 29.6 between 0.98 because we need less than 2% to be defective. Hence, PR X is less than 30.4 has to equal 0.99. Now we can do this. PRZ is less than A is equal to 0.99. And then you can, for Z, you have to do this 30 minus 30.4 minus the mean divided by standard deviation. And to find Z, for using this formula, you can use inverse normal and you get 2.32. So we can do this 2.32 equals 30.4 minus 30, because 30 millimeters is the mean, divided by standard deviation. And when you solve this, you get standard deviation is 0.17 millimeters. Part G, the weight of controllers is modeled by the probability density function below. They want us to find the expected value in here. Mean weight. To do that, we just use the formula if W equals integral of 330 to 90 W times C of W. That's 306. Now part H, we have to find the probability that a randomly selected controller weighs less than the mean weight of the controllers, and that's going to be the integral of 306 to 290. Whose mean here is 306 W dW. That equals 0.5248. 2018 done. We're moving on to 2019 now. Now we're looking at concepts in maths land, and we're given the random variable of L, which is normally distributed with the mean of 10 minutes and standard deviation of 4 minutes. And we want to find the proportion of concerts beginning before the scheduled time. So anything before scheduled time is when L is less than 0. Evaluate that using a CAS, you get 0.0062. Part B, now we have to find the probability that a concert begins more than 15 minutes after the scheduled time. And that's when L is greater than 15. Like that with the CAS being small. Now, if a concert begins more than 15 minutes, the cleaner is given an extra payment of $200, and if it begins 15 minutes after scheduled time, he gets an extra payment of 100. And if it starts at the scheduled time, there's no extra payment for him. So $100 for C is basically your answer from, $200 for C is your answer from here, part B. So you can write that directly here. You've tried 3 decimal places now, so just be careful. And 0, you can use your answer from part A over here. Find this value here. Just subtract the sum of the other 2 from 1, and you get 0.888. Okay. Part II, we need to find expected value now. That's just 0.006 plus 100 times 0.888 plus 200 times 0.106. That simplifies to $110. And deviation, that's square root of e of x squared minus, evaluate that on your CAS, you get standard deviation is 32. Part D, confidence intervals. Given n equals 1000, and it's collected as a simple random sample, and we're given that this is 43. You can just evaluate this on your CAS, and you get 0.030, 0.056. That's when X, the successes, is 43, N equals 1000, and confidence level is 0.95. Part II, you have to write a sentence or two here. You can just write that the proportion of concerts greater than 15 minutes late at Matt's land is outside the confidence interval. Should be enough, I think. Part E. Now we're given this probability density function because they're changing up how the concepts work now. And they want us to find the expected value of M. So E of M equals infinity to 0, x times f of x dx. And you get 2. Fi, now we have to find the probability that a concert starts more than 15 minutes after the scheduled time. And that's PR, M is greater than 15. That's equal to this. They don't ask for decimal values, so I just kept that as a fraction, 4 on 289. Part II. The next 9 concerts begin no more than 15 minutes after the scheduled time, and the final concert begins more than 15 minutes of the scheduled time. All right, so keep this in mind. PR M is greater than 15 is 4 on 289 from the previous question, and PR M is less than or equal to 15 is 1 minus that answer, which is 285 on 289. Now to find what the question is asking us, the next 9 concerts can't begin more than 15 minutes. So that's 285 on 289 to the power of 9 because it's 9 concerts. Multiplied by 4 on 289 because the final concert can begin more than 15 minutes, and simplify that to get 0.0122 to 4 decimal places. Part II. Now we need to find the probability that a concert begins up to 20 minutes after the scheduled time, given conditional probability that it begins more than 15 minutes. And that's when M is less than 20, given that M is greater than 15, which is 15 divided by greater than 15. To find the numerator, just do the integral of 20 to 15 f of x dx and divide that by the answer from part F, 4 on 289. That's what we found there. That simplifies to 195 on 484, which is 0.403 to 3 decimal places. That's 2019 done. Let's move on to 2021. Question 4. We're given 2 air pumps, pump A and pump B, and the inflations are independent of any other inflation. And when pump A is set to 320 kPa, it's normally distributed with the mean of 320 kPa and standard deviation of 10 kPa. And part A is asking us to find the probability that a tire will be inflated to pressure greater than 330. So that's basically PR A is greater than 330. Use norm CDF when you CADs, get 0.1587. Part B. Now we want to find the probability of this pressure greater than A 0.9, and that is A is greater than little a equals 0.9, and that is PR x of A is less than A equals 0.1. So now you can use normal inverse normal. And once you use it, you get A equals 307.184. But you can find it to the nearest kilopascal. So that's 307 kPa. Now we're moving on to pump B, and we're given the following probability density function. Now we have to determine the mean for part C. That's E of x equals 230 to 310 x times b of x dx. That's equal to 322 kPa. Part C is done. Part D, a randomly selected tire is inflated by pump B, and we need to find that when the pressure is greater than the mean to 4 decimal places. So that's basically PRB greater than 322, because it means 322 from the previous question. You can use this integral to solve that. E of x dx. And that simplifies to 0.5248. That's part D. Part E. Now we need to find the probability that tire inflated to pressure less than 0.95. Okay, so that's going to be 310 x dx equals 0.95. You can use the solve function in CAS to evaluate for k, and k equals 328 kPa. Part F, the motorist is equally likely to use either pump A or pump B, so that's half chance for each. And we want to find the probability that the motorist use pump A, given that the tire is inflated to a pressure greater than 325 kPa. That's going to be probability of A given x is greater than 325, is the intersection of A and x is greater than 325 over the probability of x is greater than 325. So for the top part of the fraction, we can just do half, because we have a half chance of choosing A, multiplied by 0.308. To get that, you just use norm CDF 325 comma infinity, and then your mean and standard deviation. And the denominator is half again, times 0.308. That's the chance of A having greater than 325 pressure, multiplied by, add that by B's chance, which is half times 0.261. To get this value, you can just use the integral of 330 to 325, dx dx. Once you simplify that fraction out there, you get 0.5411. That's part A. Part G. Okay, so we've got that pump's got to be defective, and P is 0.08. We need to find probability that 4 pumps are defective from a sample of 25. So we can tell that N equals 25 and P equals 0.08 based on the information we have from the question. And I'll use D equals 4. Exactly 4 are defective. That's 25, because that's the sample size. C 4. We want 4 defectives, 0.08 to the power 4, multiplied by 0.92 to the power 21. That equals 0.0899. That's part G. Part H. For random samples of 25 pumps, we're given this random variable, which is the proportion of pumps that are defective. So now we want to find probability that P hat is greater than 15%. Okay. So that's this. p hat is greater than 0.15, PR of D 375. We want to get in terms of D now. The reason it's 3.75 is because P hat equals X on N. And we know that P hat is 0.5, given in the question, equals X on 25. That's the random sample size. So cross multiply, you get X equals 3.75. Okay, so we can't have it in terms of 3.75 because then we can't use our CAS to evaluate it. So let's move up to the next whole number to get this. Use your CAS and you get 1.351. Yeah, part H is done. Final part of the question, part I. We want to find the least value of n such that this function, this thing here is obeyed. So PR of P hat n is less than 1 on n, is less than 0.15. That simplifies to PR n P hat on n times 1 when you cross multiply, less than 0.15. Finally goes down to PR x is less than 1, which is PR x is 0. The reason n p hat of n is equal to x is because p hat n, and when you cross multiply, you get this. Now we want to evaluate PR x equals 0, and that's binomial n choose 0 times 0.08 to the power of 0 multiplied by 0.92 to the power of n. And to solve for n, you just do 0.92 to the power of n is less than 0.15 because we want that condition. And we get n is greater than 22.75. And we want the least value of n as a whole number as well. So n equals 23. That's all of NHT probability.
Thank you.